What's up, guys? This is Mr. Myasis here, and I am working on solving trig equations. Now, we are going to look at two parts. I've got part one video is going to look at solving trigonometric equations. Trigonometric. It's a tough word to say really fast. That's why we normally just cut it short and say solve trig equations. So I'm going to look at solving these trig equations for a specific interval. So we're gonna focus all of our energy here on 0 to 2 pi. So basically one revolution around the unit circle. But I can really ask for any interval, and then in the next video you'll see what happens if we don't have an interval and we want all values, and I'll show you what that means. But right now we're going to focus in on just the unit circle. So if you have your unit circle handy, have that out. Whoa, what's it doing? Have that out so that we can you can follow along. So check this out. Here's what we're going to do here. We've got this equation, 2 sine x minus 1 equals 0. So what you want to do for any of these problems is you want to make sure that you solve for the trig function. So you're solving for this entire sine part first. So to do that, we're gonna add 1. Okay, we're gonna add 1 to both sides, and then we're gonna divide by 2. So we're gonna have sine x, right, a little bigger here, equals 1/2. All right, sine x is 1/2. Now we're not going to take the inverse sine. I know some of you are tempted to go, oh yeah, well, I know how to do this. We did it before. We did this. We said x, the inside is going to be equal to the inverse sine of 1/2. Well, here's the problem with that, guys. Is that if you do the inverse sine, remember that the inverse sine has some restrictions, right? The restrictions for inverse sine are between pi over 2 and negative pi over 2. Well, the thing is that this x could be anything to give me 1/2. So we're not really doing the inverse, okay? So in these cases, when we're solving a trig equation, we're not really doing the inverse. We're actually just we're going to do the same thing that we would do in the inverse. So we're going to look for the sine of x being 1/2. Remember that x is the angle that gives me 1/2 for the y value. So where is that? Well, that's right here. And where else? Right here. So in this case, I've got two answers, pi over 6 and 5 pi over 6. You're going to find out, guys, if this is your first time watching one of my videos that I do on the computer here, you're going to see that I have trouble with 5s for some reason. Okay, so these are my answers. I got two answers within 0 to pi over 2. All right, let's take a look at another one. So we've got sine 2x equals sine x. So this is a double angle here, right? This is a double angle, and we've been working with double angle identities. So I'm going to change this using my double angle identity. 2 sine x cosine x equals sine x. Now some of you might be thinking, hey, Mr. Myasis, can't I just divide sine x and divide sine x and then get rid of it and have 2 cosine x equals 1? No, you can't do that. Listen, guys, we never divide by what we're trying to solve for. We have an x here. We don't want to divide it out, because what if it's 0? It's not going to work. So what we actually have to do is we have to subtract sine x from both sides. All right, this is what it's going to look like. It's going to look like 2 sine x cosine x minus sine x equals 0. So again, don't try to divide sine x. A lot of people do that, and it's not right. Once you bring the sine x over, you're going to factor it out. All right, so we're going to have 2 cosine x minus 1. So then I get sine x equal to 0, because remember this is the zero product property. 2 cosine x minus 1 equals 0. Now I solve, so I add 1, divide by 2, right? Add 1, divide by 2. Just like I'm solving for a linear equation here. 1/2. All right, so now I got to solve each of these separately. So here I'm going to say, okay, well, what x value is going to give me the sine of 0, which is, or the sine going to be equal to 0? So the y value 0 is there, y value 0 is there, and I want to be in between 0 and 2 pi. So I have 0, pi, and 2 pi. So what about this one? Well, we're going to look for the x value 1/2 right there. That's negative. Right there. So we got pi over 3 and 5 pi over 3. Again with those 5s. And this is my answer. Again, I have this case, I have 5 possible values of x. Okay? Let's take a look at another example. 2 plus cosine 2x and equals 3 cosine x. Again, we're going to make sure that we have everything on one side. We're going to change this guy here. So I'm going to change this to 2 plus 2 cosine squared minus 1 equals 3 cosine x. So then I'm going to bring this over here. So I'm going to have 2 minus 1, which is 1. Put that right here. I'm going to bring the 2 cosine squared in the front. And I'm going to subtract 3 cosine x. And I equal it to 0. Okay, so I subtracted 3 cosine x, and I just shifted this around, reordered it so that I've got a quadratic. And I'm going to factor it. Cosine x minus 1 times 2 cosine x minus 1. All right, this is a factorable quadratic, and this is how it factors. I'm going to put each of those equal to 0. Cosine x minus 1 equals 0. 2 cosine x minus 1 equals 0. I'm going to solve for each of these. 1/2 cosine x equals 1. All right, so let's take a look at what we got here. We want the x value to be 1. That's going to be here, well, on there, right? So it's going to be 0 and 2 pi. Again, we're in this interval. And then we want their x value to be 1/2, which is at pi over 3 and 5 pi over 3. And these are our solutions. Okay? All right. Let's, of course, you always want to check to make sure it works. All right, so you plug 0 back in here, plug 0 back in there. It should all work out. Okay, let's take a look at the last one here. Sine x equals tangent x. Well, we could do this one of two ways, guys. We could think about, well, what angle will I have the sine x, which is the y value, equal to the tangent, which is the y value over the x value? That might be a little bit of a struggle here. So what we're going to do is we're going to go and try to solve this by changing tangent into sine over cosine. And then I'll go and multiply cosine on both sides. Sine x cosine x equals sine x. And this is a lot like the second one we did. So we're going to bring the sine x to this side by subtracting it. Factor it out. Honestly, don't know why I changed my tone there. And then we set each of those equal to 0. Okay, so here we're going to have cosine x equals 1. And where is cosine x equal 1? That is going to be at 0 and 2 pi. Where is sine x equal to 0? That's going to be at 0, pi, and 2 pi. All right, so let's think about this. Sine over cosine is going to be 0, 0. Yeah, these are all going to work. So since this one includes these two, all I have to do is box this one. Because, 0 is here and 2 pi is here, which is over here. All right? And that would be our answer. Okay? So this is solving some equations using an interval. And again, guys, we're going to do stuff by factoring. We're going to, we're like this one, we factored it out. If we have a double angle here, we want to make sure we change the double angle formula. You'll see some other ones that we do in the next video that are a little bit more advanced too. All right, so those are some strategies, and that is my video for you guys. Take care.